Now let's do multiplication. So multiplication of complex numbers. Okay. So the question can be determine, call this example 4. So determine the product of the two complex numbers. Determine the product of the following complex numbers. All right. So let's use the same number that we used. Unless you want another number, then you can provide it. So I suggest we use the same number so that you can see the difference. So the same numbers are -4 plus 6i and -2 minus 9i. So let's perform the multiplication there. If you like, you can write your product equal to, then you set it up yourself. -4 plus 6i bracket -2 minus 9i. Okay, so who has an idea of what we need to do and tell us the process, and we take it from there.
Wouldn't you multiply -4 times -2 multiply -4 times -9i?
Okay, that's a good idea, but it has a name. What you just told us now has a name. What is the name? What is it called?
Distributive property.
Distributive property. Thank you. So you are going to use distributive property. So when you are writing an exam and they say justify your solution, that's the kind of vocabulary that you use. So you can just say use distributive property, right? So, and that tells somebody what you're about to do. So using that, let's just go ahead and do it very quickly. The product ranking, this is answering your question. So now -4 multiplied by -2. So first of all, perform the multiplication of the sign. Negative times negative is positive. So you write your positive. 4 times 2 is 8. Then you repeat the process. -4 times -9i. So negative times negative is positive. You have your plus. 4 times 9 is 36. You have your 36i. Then you try the same thing with 6i. So 6i multiplied by -2 will give us -12i. And then positive times negative would be negative. 6 times 9 is what? What is 6 times 9?
54.
54. You have your 54. Then you have I and I. I times I is what?
I squared.
I squared. Thank you. Thank you. So then I squared has its own definition, but let's factorize first. Not factorize. Let's collect it like terms first. So this is 8 is by itself. So you just write 8. 36i minus 12i is what? So 24i. Is it positive or negative?
Positive.
Plus 24i. Then on this one, so I squared, the definition of I squared is square root of, actually, square root of I squared is equal to -1. So anytime you encounter an even number of I, it is negative. So I squared is -1. Oh,
Mr. Ukaegbu,
I
where did
squared
you
is
get?
-1. I'm sorry.
Where did
I
you get
squared is
20?
-1. So you are having minus 54 parentheses -1.
Mr. Ukaegbu,
Yes.
where did you get 24 from?
36 minus 12. Is it not 24?
Okay, I didn't.
Okay. All right, no problem. So now you see, this is I squared is -1. So 54 times -54 times -1 changes to positive. So this turns to plus 54. And this turns to the same thing, 24i plus 8. Okay? So we are not done yet. There's another like term you can combine. 54 and 8 are like terms. So that gives us what?
62.
62 plus 24i. And that's the product. So you can see you can see that the number is in this form, A plus BI. Okay? So now let me give you another trick, how they frame the question sometimes. They can say, instead of saying, determine the product of this, they can say, how can you write the product of this in form of A plus BI? Let me write it down, how question is framed.
Wait, Mr. Ukaegbu, why did you change it to positive 54?
Because negative 54 multiplied by negative 1 is positive. And I squared is defined as negative 1. How is it negative 1? We already know that I is equal to square root of negative 1, right? That's the original definition. So if you square both sides, you have I squared equal to square root of negative 1. And that eliminates the square root, and retains the number inside. Negative 1 is I squared. That's how they get that I squared to be negative 1. Okay, so here's what I wanted to frame up. I said, how can you write the product of this? How can you write the product of original number we had? So this is typically how the question is framed. How can you write the product of this and this in form of A plus BI? So this is how they frame the question. All right?
Mm-hmm.
You got it now? Okay, so now let's do one more thing and then I will let you go. Time now is 9:40. We have about 15 minutes. So there is something I want to define, and that is called complex conjugate. So definition, complex conjugate. Okay, now this definition is very important, so you need to remember it. If you like, memorize it. There's nothing wrong with that. So a complex conjugate are complex numbers with equivalent real parts and opposite imaginary parts. Let me write it down. Okay, let me repeat. Complex conjugates are complex numbers with equivalent real parts and opposite imaginary parts. Okay, so now here's what that means. If your complex number is A plus BI, then it's complex. So you retain the real part. The real part is this side, the A, you retain it the way it is, but you change the sign of the complex part. Whatever that sign is, you change it. If it started with negative, you change it to positive. If it started with positive, you change it to negative. So for example, let us use the same number that we had. Example, the same number that we used. So example, negative 4 plus 6i. So what is the complex conjugate of this?
Negative 4 minus 6i.
Exactly. So its complex conjugate is negative 4 minus 6i. Let's do another example using the other one. This is A, B. What is the complex? So what is the complex conjugate of this number?
Negative 2 plus 9i.
Exactly. So it is answer.
Is it almost
negative
like
2. Hello?
I said, so is this kind of like similar to like absolute value?
No. There's a slight difference. It looks like it is. Hold on, I will explain. So it is negative 2 plus 9i. Okay, so now in the case of absolute value, which you mentioned, absolute value is used when you want to ensure that your answer remains a positive number. That's when you use absolute value. A situation, because there are certain situations whereby you cannot have a negative number. All right. For example, if you are talking about football field, you want to let's say you want to find the area of a football field. So all your numbers are going to be positive because if you take a tape measure and measure the length and the width, it's going to give you a positive number. So you cannot really have a negative number in that case. So if, for example, how you are manipulating your numbers and it turns out to be negative, you have to use absolute value to make it positive, because in the real life, it is not possible to have a negative football field. It doesn't exist. Okay, so now complex conjugate is very useful, very, very useful in doing certain things in complex numbers and also in radicals and complex numbers. That's where you have conjugates, most especially. So we have, we pretty much, please type in your name on the chat box. Type in your name quickly, please. All right, so the ending task is very easy. Ending task is very easy. It's very easy. I hate late work. That's why I give you something you can finish up in 2 minutes. So here's the task. Okay, here are the numbers. A. All right. So I have given you the task. Very, very easy. You have 5 minutes. Do it now.